Started. Alright, students, you don't have a math class today. You have we will do some problems now on friction and NLM. I mean NLM with and without friction. So let's start with this problem. We talked in the morning today. ఈరోజు మార్నింగ్ మాట్లాడాము. So the problem says I've got a rod of length L which is kept on a surface which is of type it is frictionless till here, it is frictional from here. Coefficient of friction till here is 0, coefficient of friction from here is mu. So half part of this, I mean part of the surface is frictional surface, part of this is frictionless surface. The rod is kept on the frictionless surface with its edge coinciding with the partition of frictionless and frictional surface. I project this rod with velocity v naught. I have to find out minimum velocity v naught for it to cross this completely enter the frictional surface. Or I have to find out velocity as a function of time, and sorry, position as a function of time and velocity as a function of x. And all these functions we have to find out. So for anything, what do? We need acceleration. Once we get acceleration, we are done. To get acceleration, what do? We draw FBD and then write F is equal to ma. From there, I get the acceleration. But to draw the FBD, I need a reference frame. So I choose ground as reference frame. And let the position of the rod after a certain time interval, delta t, or some time t, be like this. Let it penetrate by amount x into the frictional surface. So it will have friction on this part, no friction on this part. If mass is m naught, length is L naught, its mass of complete rod is m, mass of part x would be mx by L. So mass of this part is mx by L. So friction on that is kinetic friction, which is mu times n, mu times mx by L into g is the friction, because normal reaction is mx by L into g. How many of you were there in the morning? Only, I think Ashrita and Shravani were there. Right? Gayatri and Bhavna, you were not there in the morning, right?
Yes, sir. Sir, I also not there, sir. In morning
Okay, you were
class.
not there. Oh. Anyways, this problem I'm doing, I didn't discuss this problem in the morning. I just gave the question in the morning. I'm discussing the problem now. The question is, I have a rod of length L. I project this rod along the surface with velocity v naught. I have to find velocity as a function of x and time. All right, and the surface is such that it is frictionless till here, frictional surface from here. Mu equal to 0 till here. This part is mu equal to 0, and this mu is equal to friction is mu here in this region. So after a time, some instant t, let x enter into this region. So friction on this part would be mu mx mu x by L mx by L into g. And gravitational force is mx by L into g, because mass is mx by L. For total length L, mass is m. For length x, it is mx by L. So I'll have some velocity v. It will be less than v naught because it is retarding. Particle is retarding, and acceleration is towards left. And what is the acceleration now? It is mu mx by L into g divided by total. I'll write the force equation. Mu mx by L into g force is equal to total mass into acceleration. Total mass is m into acceleration. Now, when I write the RHS, I need to write the total mass. because this force is affecting the total mass. So m gets cancelled out. So A is equal to mu xg by L. I get A, which is opposite in direction now. Alright. So if I write this as dV by dt is equal to minus mu xg by L, because V is towards right, A is towards left. So acceleration is opposing velocity, that's why particle will retard. Eventually it will stop. The condition is, the requirement is, what should be velocity V naught such that the whole rod should enter this frictional region. Are you able to follow this? Hello, Divya Vani. Okay, are you able to follow this? To the extent I've told, have you followed? Do you all understand how I got the acceleration?
So can you repeat once again?
Yeah, sure. I'll do it. Question అయితే అర్థమైంది కదా?
Yes, sir.
ఓకే. నౌ ఇప్పుడు చూడండి, కొంచెం పార్ట్ ఫ్రిక్షనల్ సర్ఫేస్ మీద వెళ్ళింది అనుకుంటే దాని మీద ఫ్రిక్షన్ ఎంత ఉంటుంది? కైనెటిక్ ఫ్రిక్షన్ ఉంటుంది, బికాస్ రిలేటివ్ వెలాసిటీ ఉంది బిట్వీన్ ద సర్ఫేసెస్. ఫ్రిక్షన్ కైనెటిక్ ఉంటుంది. వాట్ ఇస్ కైనెటిక్ ఫ్రిక్షన్? ఆల్వేస్ ఇట్స్ మ్యూ టైమ్స్ n. మాగ్నిట్యూడ్ ఇస్ మ్యూ టైమ్స్ n. ఆపోజిట్ డైరెక్షన్ ఆఫ్ రిలేటివ్ వెలాసిటీ. వెలాసిటీ టువర్డ్స్ రైట్ ఉంటే ఫ్రిక్షన్ టువర్డ్స్ లెఫ్ట్ ఉంటుంది. ఫ్రిక్షన్ ఎంత ఉంటుంది? మ్యూ టైమ్స్ n ఉంటుంది. n ఎంత ఉంది? mg ఉంటుంది. m ఎంత ఉంది? ఫర్ క్యాపిటల్ M, ఫర్ లెంత్ L, మాస్ ఇస్ క్యాపిటల్ M. ఫర్ లెంత్ x ఎంత ఉంటుంది? mx by L.
Yes, sir.
So mx by L into g is my gravitational force. So n is equal to mx by L into g. Mu into n raste mx by L into g is my frictional force. Now this frictional force is equal to mass into acceleration. But what mass will I take? I'll take the total mass. ఎందుకంటే ఇక్కడ ఫోర్స్ ఏం లేదు, ఓన్లీ దీని మీద ఫోర్స్ ఉంది, బట్ ఇట్స్ ఎఫెక్టింగ్ ద హోల్ మాస్. యాక్సలరేషన్ ఏమో మొత్తం మాస్ మీద, ఇట్స్ ఫోర్స్ ప్రొడ్యూసింగ్ ఎన్ ఎఫెక్ట్ ఆన్ ద టోటల్ మాస్, నాట్ జస్ట్ దిస్ మాస్, రైట్? సో ఆ టోటల్ మాస్ ఇంటూ యాక్సలరేషన్ రాస్తాను. Mass gets cancelled out. I'll get A is equal to mu x g by L. But A I can write as dv by dt.
Yes, sir.
It is retardation, so dv by dt is equal to minus mu x g by L. ఇప్పుడు కానీ ఇలా రాయచ్చా నేను? dv by dt ఇప్పుడు ఇంటిగ్రేట్ చేయలేను కదా, ఇక్కడ x ఉంది, ఇక్కడ t ఉంది. So what I'll do now is I'll write v dv by dx is equal to mu x g by L. ఇప్పుడు x ఉంది, ఇక్కడ ఒక పారామీటర్ x ఉంది, ఇక్కడ v ఉంది. v dv ఇంటిగ్రేట్ చేయొచ్చు, x dx ఇంటిగ్రేట్ చేయొచ్చు. క్రాస్ మల్టిప్లై చేస్తాను. v dv is equal to minus kx g by L into dx. I integrate this now. ఎక్కడి నుంచి ఎక్కడి వరకు? 0 to L. 0 దగ్గర వెలాసిటీ v naught ఉంది, దట్స్ ఫైన్. When x is equal to 0, my velocity is v naught. When x is equal to L, my velocity is 0. I'll get the condition between v naught and L. That's it. That's the question, right? I want to find out what is the velocity, minimum velocity required v naught, such that it should completely enter into the frictional surface. ఆ ఫ్రిక్షనల్ సర్ఫేస్ ఉన్న రీజన్ లో మొత్తం ఎంటర్ కావడానికి వెలాసిటీ ఎంత ఉండాలి? వెలాసిటీ తక్కువ ఉందనుకోండి, కొంచెం వెళ్ళి రిటార్డ్ అయిపోతుంది. ఇంకో కొంచెం ఎక్కువ ఇస్తే ఇంకొంచెం లోపలికి వెళ్తుంది. ఎక్కువ ఇచ్చేస్తే లోపలికి వెళ్ళిపోతుంది. బట్ ఐ జస్ట్ వాంట్ minimum velocity for it to reach the surface, frictional surface. అంటే it should just go and stop here. ఈ రాడ్ ఏమో ఇక్కడ నుంచి ఇక్కడ వరకు వచ్చి స్టాప్ అవ్వాలి. Is that okay?
Yes, sir.
ఇప్పుడు దీన్ని ఇంటిగ్రేట్ చేద్దాము. ఇంటిగ్రేట్ చేస్తే దట్స్ ది ఆన్సర్. v square by 2 under limits v0 to 0. I remove this negative sign and I invert the limits here. I make it 0 to v0 is equal to mu x square g by 2l under limits 0 to l. 2 gets cancelled out. I'll have v0 square mu l square mu gl. So v0 is equal to root of mu gl. So if velocity is greater than or equal to this one, this rod will definitely enter into the frictional surface. Is it okay? అర్థమైందా?
Yes, sir.
Okay, okay, good. Students, why were you not there in the morning?
We had college, sir, today.
Oh, you had college today. All right, all right, all right. Then you should have informed before itself, no? Like you will not have, if you have college, let us not keep class like that. Let's not conduct a class when you have college like this. All right, let us know before itself if you have a holiday or not. So now we'll ask you. Next time we'll let you know. Like we'll ask you whether you have a holiday. Holiday lekunte, let us not keep a class like this. All right. Okay. Now let us do the other way around. The other way around, and let us say there is frictional surface here. Let's say coefficient of friction over here is mu, and coefficient of friction over here is 0. Now I project a velocity v0. Now I have to find out velocity such that it completely enters into this frictionless surface. All right, you just practice. If you want, you can try. Oh, Bhavna, good, good. Did you enjoy?
Yes, sir.
Okay, good. You had freshers party. Very good. So enjoy, Sarah.
Yes, sir.
Good, good, good. Okay. So you had a chance to interact with seniors.
Sir?
Seniors to interact, Ayara.
Yes, sir.
Mm-hmm. Okay. Good. Yeah, such events are important. You should not miss such events. Okay. Now again, I'll do the same thing. I'll project this to a certain extent on this frictional surface x over here. So this will be L minus x. For L naught, mass is m. For L naught minus x, mass would be how much? M into L naught minus x by L. That's the mass of this part. That is lying which is lying on the frictional surface. Because ultimately I want friction on this part. ఇక్కడ friction లేదు. I want friction on this part. I'll write down frictional force is equal to mass into acceleration. Same thing. Alright. Now what do I do? What is the frictional force on this one? Mu mg. Mu n. Where n is mg. In this case it is simple because n is mg. Mu n into mg and then the m is this much. Mg. Mu times this is equal to mass times acceleration. So m gets cancelled out. So A is equal to mu times L minus x by L into G is my acceleration. I'll again write v dv by dx is equal to this much. Okay, again. I got acceleration is equal to negative of this one. Right, I got the magnitude from here. And so A is equal to negative of this one because velocity is towards right, acceleration is towards right, it's retardation. So I'll write v dv is equal to mu times L naught minus x by L naught into G dx. I integrate now. X 0 ఉన్నప్పుడు velocity v naught ఉంది. X L ఉన్నప్పుడు velocity 0 అయిపోవాలి. So I'll invert this limit 0 to v naught because I've got a negative sign here. I'll invert the limits. But 0 అవుతుందా? నేను 0 అవ్వాలని ఎందుకు అనుకుంటున్నాను? Because particle is retarding. As it goes on retarding, ఇది కొంచెం రైట్కి వెళ్ళింది అనుకోండి, frictional force is reduced, but it's still towards left. Velocity towards right ఉంది, frictional force is still towards left. That means retardation, particle is acceleration is towards left. Velocity and acceleration are in opposite directions. That means particle is always retarding. Retarding అయినప్పుడు the particle, there is a chances the particle comes to rest eventually. All right. It may or may not come to rest. Let's say ఇది మొత్తం frictionless మీదకి వచ్చినప్పుడు ఏదో velocity ఉంది, అయితే ఆ velocityతో వెళ్ళిపోతుంది కంటిన్యూస్ గా బికాస్ ది ఫ్రిక్షన్లెస్ సర్ఫేస్. అదే ఇక్కడ వరకు ఆగిపోయింది, ఇక్కడ దాని ముందే ఆగిపోయిన ఛాన్స్ ఉంది, ఆర్ ఇది జస్ట్ ఇక్కడ వరకు ఆగడానికి ఛాన్స్ ఉంది. But once it crosses that, it will never stop. It will go ahead with constant velocity. All right, so I'll have v naught square by 2 is equal to mu times L naught x minus x square by 2. So I substitute limits 0 to L naught. So which is L naught gets cancelled out, L naught square by 2. So v naught square is equal to 2 mu g times L naught gets cancelled, L naught by 2, L naught by 2. So v naught is equal to root mu g L naught. I got the same thing. All right. దీనికి when we do some SHM question, we'll solve this again and we'll get x as a function of t. Then you'll understand the beauty of the problem then. All right. ఇక్కడ footnote లో రాసుకోండి, we'll revisit this problem when we do SHM. Or sometime again when you have time like this, where we can solve only problems for Iit-Jee concerned, Iit-Jee and advanced level. అప్పుడు మళ్ళీ ఈ ప్రాబ్లమ్ మళ్ళీ సాల్వ్ చేస్తాము, where we'll find x as a function of t. ఇప్పుడు b as a function of x కనుక్కున్నాం కదా, like we have written v dv by dx and I've written a is equal to a. So I'm integrating v dv and a dx. But then we'll write v వచ్చేసాక dx by dt రాసి we'll get x as a function of t. దాన్ని differentiate చేస్తే we'll get v as a function of t. So we'll get as a function of t and we'll see how that is even more interesting. ఇంకా రెండు సేమ్ ఎందుకు వచ్చి అప్పుడు అర్థమవుతుంది మీకు. All right. Can I raise this or any doubts in this, students?
సార్ ఇంటిగ్రేషన్ అర్థం కాలేదు సార్.
ఇంటిగ్రేషన్ అర్థం కాలేదా? ఓకే, నేను కొంచెం డైరెక్ట్ రాసేస్తాను స్టెప్స్, ఎందుకంటే చూడు p dv ఎంత p స్క్వేర్ బై 2, అదైతే ఓకే కదా. ఇప్పుడు ఇక్కడ mu g by L naught కాన్స్టెంట్, ఇది L naught minus x ఇంటిగ్రల్ dx ఫ్రమ్ 0 to L naught. అదెంత ఉంటుంది? mu g by L naught టైమ్స్ ఇంటిగ్రల్ L dx ఎంత ఉంటుంది? వాట్ ఇస్ ఇంటిగ్రల్ L dx? L naught బయటికి వస్తుంది, ఇంటిగ్రల్ 1 dx. What is integral 1 dx?
One.
X. Integral 1 dx is x. దీన్ని డిఫరెన్షియేట్ చేసి 1 రావాలి నాకు. చూడండి x పవర్ 0 కదా, x పవర్ n plus 1 by n plus 1. సో x పవర్ 0 plus 1 by 0 plus 1.
Yes.
x వచ్చేస్తుంది. సో ఇంటిగ్రల్ 1 dx is x. అది రాసిస్తాను n నాట్ ఇంటూ x మైనస్ ఇంటిగ్రల్ x dx ఎంత ఉంటుంది?
For x square by 2.
కరెక్ట్, 0 to n. అంతే, ఇప్పుడు లిమిట్ సబ్స్టిట్యూట్ చేయడమే. అప్పర్ లిమిట్ మైనస్ లోవర్ లిమిట్. అప్పర్ లిమిట్ సబ్స్టిట్యూట్ చేస్తే ఎల్ స్క్వేర్ వస్తుంది, ఎల్ స్క్వేర్ బై 2 వస్తుంది. ఎల్ స్క్వేర్ మైనస్ ఎల్ స్క్వేర్ బై 2 ఇస్ ఎల్ స్క్వేర్ బై 2. ఎల్ స్క్వేర్ బై ఎల్ ఇస్ ఎల్ క్యాన్సిల్ అయిపోతుంది, ఇక్కడ 2 వస్తుంది, ఇక్కడ ఒక 2 ఉంది, ఇక్కడ ఒక 2 ఉంది, క్యాన్సిల్ అయిపోతుంది. ఎల్ గెట్ మ్యూ జీ ఎల్.
Yes, sir, I understood.
యా, ఓకే. Okay, now I'll just give you a problem as a homework you try. The mass ఏమో it is not constant but varying with x as lambda naught into e power minus x by l. ఇలా వేరీ అవుతుంది. ఇంటర్ మాస్ డెన్సిటీ is varying like this. అంటే ఇక్కడ చాలా డెన్స్ ఉంది. ఎలా అంటే ఫస్ట్ కేస్ చేద్దాము. సో దిస్ వన్ విల్ డు ద ఫస్ట్ కేస్. We just want to frame the integral, okay? We're not bothered about the integral answer. Coefficient of friction is mu, here is mu, here is 0. ఇది x అనుకుంటే from here it is measured as lambda x, lambda naught into e power minus x by l. ఇక్కడ నుంచి
The screen is not visible.
Sir,
because, yeah, just a second, sorry.
No, sir, someone is sharing the screen.
Yeah. Okay.
Ashrita, can you please once check yourself? Ashrita? Ashrita?
Ashrita, I'm saying something.
Ashrita, are you? Yeah. Okay. Now it's fine, sir. Yeah.
All right, ma'am. Thank you, ma'am. All right. So linear mass density is varying as lambda naught into e power minus x by l, where x is varying from here. All right, ఇది x. ఇది origin అనుకుంటే ఇది x. So here it is thicker. As I go away, it's becoming thinner and thinner. I mean, less denser and denser. Thickness అలానే ఉండొచ్చు, but here it's material is denser. As I go away from this, materials become less denser as I go to this side. అంటే ఇక్కడ it's more heavy. As I go away, it's becoming lesser, lighter and lighter. Okay, less denser. Density vary అవుతుంది. ఇక్కడ ఎక్కువ density ఉంది, ఎక్కువ dense ఉంది, ఇక్కడ తక్కువ dense అవుతూ ఇది ఎండ్కి రీచ్ అయినప్పుడు లీస్ట్ డెన్సిటీ ఉంది. Now I have to write down the same thing. What do I do? I'll draw the FPD of this block, this part. దాని మీద ఫ్రిక్షన్ mu into n ఉంటుంది. Mu times n. And this is mxg. So mu times mxg is my force on it. But what is mx now? I have to find out the mass of this one. How do I find mass of this one? At a distance of x, at a distance of x, I consider a thin strip of width dx. All right. It's just mathematical. ఇప్పుడు రాసింది మనం రాస్తాము. ఈక్వేషన్ ఏం రాస్తాను? mu mxg is equal to total mass into acceleration. So acceleration is again mu mxg by total mass. అంతే. But mx రాయడమే mathematical part ఇక్కడ. The rest all is same. I got acceleration as a function of x. I'll write v du by dx and go further. So physics of the problem is same. Just mathematical part is extended in this one, where I have to find out the mass of the variable density rod. ఎందుకంటే రాడ్ డెన్సిటీ వేరియబుల్ ఉంది, అందుకే ఇంటిగ్రేట్ చేయాల్సి వస్తుంది. సో mx is equal to integrate lambda naught e power minus x by l dx from 0 to x is my mx. m ఎంత ఉంటుంది? టోటల్ మాస్ ఇంటిగ్రల్ lambda naught e power minus x by l dx from 0 to l. I plug these two over here. So lambda naught gets cancelled out. Mu g times integral 0 to x lambda naught e power minus x by l dx is equal to integral 0 to l lambda naught e power minus x by l dx times a. Alright, so lambda naught gets cancelled out here. I cannot cancel out e power minus x by l, e power minus x by l, because they are not constants, they are functions of x. Alright. So I just integrate this and go ahead. Will you try to integrate this? ఇది ఇంటిగ్రేట్ చేయడం వచ్చా మీకు? ట్రై చేశారా? e power minus ax integral e power minus ax dx is equal to e power minus ax by a minus a. That's the integral. Of course, plus c, but we are not bothered about c now. Okay, would you like to integrate? Or should I leave it as homework? Alright, you try this. If you don't get, we'll deal with it tomorrow.
Okay, sir.
Okay. Now one more. See, I've got a hemispherical surface. Alright. And this part of the surface is frictionless, and this part is frictional. Mu ఈ హెమిస్ఫియర్ ని ఇలా ప్రొజెక్ట్ చేశారు velocity v naught తో. Alright, I have to find out minimum velocity for which, and the mass is m, or density is rho, ఏదైనా తీసుకోండి, whichever you are comfortable with. I mean, take density as rho, it becomes easy. Density is rho naught, radius is r. I have to find out minimum velocity such that it completely enters the frictional surface. Alright, ఇది ఎలా చేస్తారు? ఇది కొంచెం పైన నుంచి చూసినప్పుడు, alright, this is a side view. పైన నుంచి చూసినప్పుడు ఎలా ఉంటుంది? ఇలా ఉంది ఇనిషియల్లీ. హెమిస్ఫియర్ ఇలా ఉంది. alright, హెమిస్ఫియర్ ఇలా ఉంది. దీన్ని ఇలా ప్రొజెక్ట్ చేశాను. I just pushed it with velocity v naught towards right. సో ఇది లోపల వెళ్తుంది. కొంతసేపు అయ్యాక ఇలా లోపల వెళ్తుంది. Now there will be friction on this part and no friction on this part. That force will be mu times n. N is equal to mx into g. ఇది x అనుకుంటే ఇది r. If this is x, mx into g is my gravitational force. Gravity is into the plane. Normal reaction is outward. N is equal to mx into g. Frictional force will be mu mx, mu into n. I'll write the same thing again. Mu mx into g is equal to total mass into acceleration. What is the total mass? 4 by 2 by 3 pi r cube into rho naught. Volume into density is mass into acceleration. Force is equal to mass into acceleration. Or if I do it now, if I do plug in mx from here, I'm done. I'll get a as a function of x. I'll integrate. I'll get velocity as a function of x. Or I'll just integrate so that when x is equal to 0, velocity is v naught. When x is equal to 2r, my velocity is 0. Now all that matters is now all that remains is to plug in mx. Mx ఎలా కనుక్కుంటారు is a question. You think about this problem as a homework. mx ఎలా కనుక్కుంటారు? ఇది లోపలికి వెళ్ళింది అనుకుందాము కొంచెం. ఈ మాస్ కావాలి నాకు. పై నుంచి చూస్తే ఈ మాస్ ఉంది, సైడ్ నుంచి చూస్తే ఈ మాస్ ఉంది. ఇది హెమిస్ఫియర్ ఇలా ఉంది కదా, ఇది సర్కిల్ ఉంది ఇక్కడ. Alright, so this is mass we have to find out. So think about it, how to find out this mass. ఎలా ఎలిమెంట్ తీసుకోవాలి నేను? ఎలిమెంట్ ఎలా తీసుకోవచ్చు నేను? ఎట్ డిస్టెన్స్ x ఒక స్ట్రిప్ తీసుకోవచ్చు, ఒక సెమీ సర్కిల్ తీసుకోవచ్చు ఇక్కడ. Okay, that diagram cannot be drawn. I'll try to draw this diagram in a PPT and show it to you how the diagram appears. But I hope you have understood. ఇలా స్లైసెస్ ఉంటాయి. ఈ స్లైస్ విల్ బి సెమీ సర్కిల్. ఒక హెమిస్ఫియర్ ఇలా ఉంటే, ఒక హెమిస్ఫియర్ ఇలా డోమ్ ఇలా ఉంటే, ఇలా స్లైస్ చేస్తే ఈ స్లైస్ విల్ బి సెమీ సర్కిల్.
Yes,
Right?
sir.
ఈ స్లైస్ రైట్. సో దట్ సెమీ సర్కిల్ ని నేను థిక్నెస్ dx అనుకొని దాని వాల్యూమ్ రాస్తే, దాని మాస్ రాస్తే ఇంటిగ్రేట్ చేస్తాను. ఎక్కడి నుంచి ఎక్కడి వరకు? ఫ్రమ్ r minus x to r. Alright, అదే ఆలోచించండి. I'm telling you the whole answer now. Alright, so you just think how to integrate, how to get the mass mx. Alright, mass mx వచ్చేస్తే I know the whole problem now. Physics of the problem is same. It's an old problem. Mathematically it's new problem, but physics of the problem is same. Physics లో ఏం కొత్త physics ఏం లేదు. Last 3 problems are the same category. Their physics is same. Do you understand that physics is same?
Yes, sir.
స్ట్రక్చర్ మాస్ స్ట్రక్చర్ వేరే ఉంది కాబట్టి మాస్ mx లో క్యాలిక్యులేట్ చేయడంలో వేరే ఉంది. సో mathematically they are little different because there is one more mathematical step, additional step in every problem. But otherwise their physics is same. Friction force is equal to mass into acceleration రాస్తాను. Acceleration వచ్చేస్తుంది as a function of x. Alright, we are not bothered with the rest. That's just simple math. Alright, we are bothered about how to frame the equation for a given situation. ఈ సిచ్యువేషన్ వచ్చినప్పుడు ఫ్రేమ్ ఎలా చేస్తారు. Now, yeah, that's it. Okay, now let's go for another problem. I've got a truck. This truck is initially going with velocity v naught. Now, there is a block over here, block of mass m naught, kept at a distance of x naught from the wall. Okay, now what happens is this truck sees some obstacle on the way, on the road, and applies brakes, because of which there is retardation of the truck a naught towards left. Obviously, acceleration is towards there. That's why I say retardation. Velocity and acceleration are opposite to each other. Truck is retarding. Now, because of this retardation, now the question is, what is the retardation for which this block will not hit the wall? Coefficient of friction over here is mu. So, do you understand the situation? Do you understand the question? Like, why does question make sense? Question sense and make chestande. I mean, do you hear the disturbance here? There's a lot of disturbance here. All right. So, okay. So where am I? So now look at this. I'll solve this from this frame, accelerated reference frame. I'll stand on this frame and draw the FBD. I'll choose the reference frame, draw FBD, write F is equal to MA. That's it. Pretty simple. All right. Now, with respect to that reference frame, I'll have real forces to be M naught, normal reaction, gravitational force M naught G. Because the friction is towards right, because acceleration is towards left, pseudo force is towards right, friction will be towards left. And what kind of friction will it be? If it is not moving, it's static friction. So let us say that is mu n, limiting friction is mu m naught G. Now, this block will start moving if m naught A, the pseudo force, beats this limiting friction. So m naught A naught, if it's greater than or equal to, no, greater than, not equal to, non-equal to is just on the verge of slipping, greater than m naught G. M naught gets cancelled out. So A naught is greater than mu G. Then this will start slipping. So with respect to this one, this block will start moving towards right if A naught is greater than mu G. అంటే ఈ రిటార్డేషన్ దీనికంటే ఎక్కువ ఉంటే my pseudo force is beating limiting friction. Pseudo force limiting friction beat చేసింది కాబట్టి this block will start moving on this platform and will move towards right due to pseudo force on the block with respect to this reference frame. ఈ pseudo force వల్ల towards right వెళ్తుంది అది. All right. Now, what is the net force on the block? MA or M naught A minus mu M naught G is equal to M naught times A relative, AX. Okay. Now that is A. What is AX now? A naught is acceleration, retardation of the truck. AX is the acceleration of the block with respect to the truck. If pseudo force is not able to beat this one, AX is equal to 0. Block will stay there itself, so it will never hit the wall. But if AX is equal to this much, that means it is going towards right with an acceleration AX with respect to the truck. M gets cancelled out. So AX is equal to A naught minus mu G. Now with this acceleration, this particle is going towards right. Alright. So initially particle is at rest with respect to the truck. Alright, truck మీద నుంచి ఉంటే particle is at rest. Why? Because particle and truck both are moving with the same velocity v naught. There is no relative motion between both the particles. So if the particle is at rest with respect to the truck, because of the pseudo force it starts moving. If pseudo force beats limiting friction, pseudo force limiting friction ki beat cheste, this particle will start moving towards right. With what acceleration? This is the fourth equation. Pseudo force minus limiting friction minus kinetic friction. This kinetic friction now. Once it starts moving, it's kinetic friction, mu mg, mu n. So ma minus mu n is equal to m times ax. M gets cancelled out. Ax will be a naught minus mu g. All right. Now, once you get that, yeah, that's it. Now I got ax, so I'll have half I want to find out time after which it will hit the wall. Half x t square is equal to x naught. So half a naught minus mu g t square is equal to x naught. So t square is equal to 2x naught by a naught minus mu g. So t is equal to root of 2x naught by a naught minus mu g. This is the time after which it will hit the wall. But will it definitely hit the wall? ఖచ్చితంగా హిట్ అవుతుందా wall కి? Yes, it will hit the wall because acceleration is towards right. ఎందుకు towards right? Because pseudo force is beating limiting friction. ఎందుకంటే అందుకే block started moving towards right with an acceleration. So block is accelerating towards right with respect to this wedge, with respect to the truck. So it will go and definitely hit the wall, provided this acceleration is sufficient enough. Sufficient enough ఏంటి? A naught greater than mu g. A naught greater than mu g ఉంటే ఖచ్చితంగా ఇది హిట్ చేస్తుంది. A naught less than mu g ఉంటే ఏమవుతుంది? అది కదలదు. Block will not move with respect to the truck. So it will remain there itself, with the force of friction being static. ఇప్పుడు kinetic friction act అవుతుంది. This equation comes when pseudo force minus kinetic friction is equal to mass into acceleration. But if A naught is not sufficient enough, A naught ఎక్కువ లేదు, that means he is slowly retarding. చాలా మెల్లగా brakes apply చేశారు this truck fellow. Then in that case what happens? The pseudo force will not be able to beat limiting friction. So the pseudo force will be less than limiting friction. So this block will not move with respect to the truck. All right. Is this problem clear, students?
Yes, sir.
Yes, sir.
All right. All right. All right. All right. Now let's look at block and block. Actually, were you there for block and block problem, students? మీరు ఉన్నారా block and block కోసం? లేరు కదా?
No, sir.
Okay. Then did you go to the did you visit the recorded lecture, Bhavna? Gayatri?
No, sir.
Oh, then how? Like, why were you not there for the class? అవును 2-3 days నుంచి ఎందుకు రావట్లేదు భావన? గాయత్రి? You are not able to follow. I mean, my question is, why are you not seen in the class? Oh, okay, okay. Bhavna has an answer. All right. All right. You performed today. Good, good, good. Then that's good. Okay. But at least recorded sessions attend చేయండి. Otherwise, block and block will be difficult. Block and block cover చేసాం మనము. All right, Gayatri, how about you? Were you there for block and block?
No, sir.
Okay. Okay. And Oscar doesn't attend in the morning. Right. He has got some issue. He says he doesn't attend in the morning. All right. So Bhaskar, you attend only in the evening, right? Uh-huh. Okay. So you may not be able to understand anything what I'm speaking now. Are you able to understand what I'm speaking? Okay. Bhavna is understanding fine. Bhaskar, are you able to understand? Okay. 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 Gayatri is able to understand. Fine. Okay. Bhaskar is trying to understand. All right. Anyways, let's get block and block problem for a few minutes. See what happens is I've got a block on another block. All right. Let's say this mass is m. This mass is also m naught. All right. Both are m naught and m naught. Just for simplicity. And coefficient of friction is mu between the surfaces. Coefficient of friction over here is 0. So this is smooth surface. This is frictionless surface, frictionless surface. All right. Now what I do, I apply some force on this lower block towards right. All right. Then what happens is these blocks may move together or may separate. Okay. That's the crux of the problem. That's what we have to decide. On what condition will they separate? On what condition will they not separate? All right. If they don't separate, they move together. That's what it means. Acha, let me know. Are you going to attend tomorrow morning?
Yes, sir.
Okay. Asita is anyway attending. Bhaskar will not attend. Okay. Anyways. So look at this. So this is accelerating system. So this block is an accelerating system, right? If I stand on this block and draw a video of this block, so there will be pseudo force on that. Pseudo force will be towards left, Fp. It has a tendency to move towards left. That's why friction will be towards right. All right. Standing on, see, whenever I have to decide static friction, it is better to decide standing on the surface on which the block is kept. I stand on this surface, which is an accelerating surface, which is accelerating towards right. So pseudo force will be towards left. Presuming the surface is frictionless, block will have a tendency to move towards left. So friction will be towards right. If the pseudo force is beating this friction, it will move towards left. Otherwise, friction will self-adjust to counterbalance pseudo force. All right. So that's what is happening. If the pseudo force is huge, on what does pseudo force depend? On the acceleration of the reference frame. Acceleration of the lower mass then is depend on the force is depend on the. So if force is huge, they will separate. If force is not that huge, they will not separate. So it depends on force as well. Of course, it depends on mu. Masses also, force, m1, m2 and f as well. F తక్కువ ఉంటే యాక్సిలరేషన్ తక్కువ ఉంటుంది. యాక్సిలరేషన్ తక్కువ ఉంటే సూడో ఫోర్స్ తక్కువ ఉంటుంది. If pseudo force is తక్కువ, if it is less than the limiting value of the friction, which is mu mg, friction will counterbalance so as to friction will self-adjust so as to counterbalance this pseudo force. If pseudo force is ఎక్కువ, if it's huge enough to beat limiting friction, this will slide towards left with respect to the surface on which I'm standing on this surface. With respect to the surface, with respect to this accelerating reference frame, which is lower block. All right. So let us see. Okay, this is what is from this reference frame. Let us see what is happening with respect to ground reference frame. With respect to ground ఏమవుతుంది? With respect to ground, if at all they are moving together, they'll move with same acceleration a naught, let's say. The only force which is responsible for this acceleration on the upper block, only force on the upper block which is responsible for acceleration towards right is friction. So friction will act towards right. All right. Reasoning to reduce the direction of friction is different from ground frame and pseudo force frame. All right. Non-inertial frame ఇంకా inertial frame లో difference ఉంది. Inertial frame లో ఎలా reduce చేస్తున్నాను? Only force responsible for the acceleration of this mass towards right is friction. So friction has to be towards right. అదే ఇక్కడ నుంచి ఎలా డిసైడ్ చేశాను? It has a tendency to slip towards left because of pseudo force. Friction will be towards right. In both the cases, my friction is towards right because friction is real force. It has got some particular direction. It cannot change this direction depending on the reference frame. Physics doesn't depend on reference frame. Reference frame change అయితే కొంచెం reasoning మారచ్చు, but conclusions will be same. All right. So friction is towards right. So reaction of that I told you. Whenever you think of a force, think of its reaction force. So reaction is on the lower block. So F naught minus F is equal to m naught times A. F is equal to m naught times A if they are moving together. I add these two. So F naught is equal to 2m naught into A. So A is equal to F by 2m. Their common acceleration is F by 2m. But if this force is huge enough such that the pseudo force on the upper block beats limiting friction, that means ma naught is equal to mu mg. M gets cancelled out. A is equal to mu g. If A is greater than mu g, then they'll separate and the upper block will go only because of friction towards right. కింద బ్లాక్ ఎక్కువ యాక్సిలరేషన్ వెళ్ళిపోతుంది, పైన బ్లాక్ తక్కువ యాక్సిలరేషన్ టువర్డ్స్ రైట్ వెళ్తుంది. Alright, it will slip on the upper block, lower block. Alright, we will do this again because you all missed block on block problems. You'll have some difficulty in understanding, but I've done it from scratch again. But the approach was different from what I did before. ఇంతకు ముందు కొంచెం బేసిక్ ప్రాబ్లం నుంచి తీసుకున్నాను. Here I've taken directly a certain situation. So I suggest you listen to the recorded video session whenever you have time. But one more thing, students, you start solving problems from the book. Alright, and you are not asking doubts. You come up with doubts, you WhatsApp to post చేయండి. I'll answer those doubts in the next class. Alright, whatever doubts you've got, you just take a pic. Yeah, good Bhavna. Good. So take a pic and send it to the WhatsApp. We'll discuss that in the next class. Alright. So don't worry about this block on block. We'll do it again. I just revisited it. One block on block master చేయాలి because block on block is an important category of problems for both mains and advanced. Advanced లో కొంచెం complicated ఉంటుంది. This is mains level itself. Advanced లో ఇంకొంచెం complicated ఉంటుంది that we have to do. Alright. Thank you all students. Bye everyone. Join the next session.
Thank you, sir.
Thank you.